Over is just about imaginary numbers. We're going to start complex numbers, but then next class we're going to do the last 3 examples. So the first thing we need to talk about, and this should be a review from Algebra 2, that an imaginary number is defined as I is equal to the square root of -1. So that's a really important fact. Anytime you see a -1 underneath a radical, I'm going to replace it with an I. Because I is equal to the square root of -1, I can also say I squared is equal to just plain -1. Because a radical times a radical, the radicals will cancel off and I'll just be left with what's underneath. So that means if I have a positive real number b, so we have the square root of -b, doesn't matter what the b is, I can rewrite that as I, because I can take the negative out and make it an I, and then just keep the b underneath the radical. So the section underneath it is just simplification. So I'm going to pull this down. And these are pretty straightforward. So we have I root 25. What's the square root of 25? So it's just 5i. Number 2, I have a negative on the end, so I have negative here. And then I can take the other negative out as an I. And then I still have square root of 81. Amber, you need this one? I must have forgotten you over there. Sorry. You're welcome. What'd you say? Negative 9i, yes. Now number 3, I can't reduce the square root of 7, so I kind of leave it like that. So all I'll end up with that one is this I square root of 7. And then I leave it like that. This one becomes I radical 44, but 44 I can reduce. So I'm going to come up with my factor tree. What 2 numbers multiply to give me 44? 4 and 11. And then 4 can be simplified into 2 times 2. My index is 2, so I'm looking for groups of 2. So I'll have 2 on the outside, I, and then square root of 11, yes. So basically, this section is doing the same things over and over again that we did before, but now with some i's involved. So the multiplication section, I'm going to do the same thing. So we have I root 6 times I root 5. I'm going to multiply them both, so we have I times I is I squared, and then square root of 6 times square root of 5 is just square root of 30. The important fact that we noted at the top of the paper, we have I squared is equal to what number? -1. So I'm going to substitute -1 in for my I, so it's just -1, or you don't have to write but negative square root of 30. And that's going to be your final answer. So the one important thing that you have to remember with the imaginary numbers ones is anytime you see an I squared, you have to replace it with -1.
So can we start still simplify it, like how we did 44?
So you can simplify one that's like number 6, but square root of 30, if I split it up, I'm back to 6 and 5, and there's no pairs that I can take out. So there's nothing I can do with square root of 30. That's as simple as it gets. But number 6, we will be able to do that. So you start off, we'll have I root 8 times I root 6 gives us I squared square root of 48. And then off to the left hand side, I'm going to make my factor tree for 48. You can split it back up into 8 and 6 if you want to. And then we have 4 and 2, 2 and 2, 2 and 3. My index is 2, so I'm looking for groups. So I have a group of 2 here, group of 2 here. Yep, negative 4, so the I squared is negative. Then we have 2 times 2 is 4, and then the 3. So that gets left underneath the radical. And that would be the final simplified version. The 7 spot, because you have more space, and 7 you don't really need space, but so 5i, but 7 doesn't have a negative sign underneath it, so I'm just going to write it as, square root of 5i, and then square root of 7. And it doesn't matter if you put the I before it or after it. Usually you want to put it before it because it looks like it's really not, but it doesn't matter what order you put it in. So we have square root of 5 times square root of 7 is square root of 35, and then we still have an I there. And I have an I in the end because I didn't have a negative and a negative in the other one. So we've simplified, we've multiplied, now we have to divide. And dividing is like when we had to rationalize the denominator of the old problems. So with this one, I end up multiplying square root of negative 5 over the square root of negative 5. So this is rationalizing the denominator. We just have complex numbers involved, or imaginary numbers involved. So just like we multiplied up top, I'm going to rewrite it. So I have square root of negative 80. I can write that as I root 80 times, there's a negative underneath here, over I root 5 times I root 5. So I have 80 and I times I, so I have I squared square root of 400.
Daniel?
Then we have I times I is I squared. And then 5 times 5, square root of 25. I squared is negative 1, so I have negative, and then square root of 400 is just 20. I squared is negative 1, square root of 25 is just 5. So my answer is just okay. From there, I want you to practice number 9. I'm going to